Hello, Year 11. Time to do 17C, which is graphs involving inverse trig functions. Now, we've already talked about the basic inverse sine graph, basic inverse cos graph, and basic inverse tan graph. We went through each of those three graphs. But we don't want to just keep with inverse sine of x. We want to change it to be a lot more interesting, like these kind of ones here. So we need some skills to help us do this. Now there's probably a few different strategies out there, but I'm going to show you the method that I like the most. And that is to always start by comparing with the basic graph that we've already learnt about. Now I've drawn it here on the side as a little visual reminder. Because this is an inverse sine graph, this was the basic inverse sine graph. Okay, we did this last lesson. It starts at -1 minus pi on 2, increasing through 0, 0, up to 1 pi on 2. And we had the domain and range of the inverse function that I've written down there. Don't confuse your domain and range of your original function with your domain and range of your inverse functions. Just try to keep those clear in your head. You will find it helpful if you basically have the basic inverse graphs memorized. It will make the rest of this much easier. Okay, so what we're going to do, we want to draw the graph of y equals 2 inverse sine of 3x. Now because I've got some stuff over there, I'm just going to bring this down here a bit. I've got plenty of space down below. So what we like to do, we like to have the trig function by itself. So I'm going to divide by 2. That would be y over 2 equals inverse sine of 3x. Okay, now the reason that I do that is because the stuff that is after that inverse sine, the things that are with the x, they affect the domain. Okay, so those parts here are going to help me work out the new domain of my new graph. And the stuff that I've moved over here, all the things that are with the y, they tell me the range. Now, how do they do that? All right, let's start with the domain. Now, the domain of my original function, my basic one, was up here between -1 and 1. That means that this 3x, okay, I have a 3x instead of an x, my 3x is going to be between -1 and 1. Okay, I get that from knowing my inverse function, my inverse sine function. So then I just want to get the x by itself. So I'm going to divide that whole inequality through by 3, which would be between -1/3 and +1/3. So that is my new domain. Let's do the same thing with the range. My range is coming from the y over 2. Now originally the range is between -pi/2 and pi/2, and that's where this starts. It starts here between -pi/2 and +pi/2. Now I want to get the y by itself in that range, so I need to times everything through by 2. -pi/2 times 2 is going to be -pi, and +pi/2 times 2 is going to be +pi. So that is my new range. Now the curve is going to keep the same basic shape as the one you see up here in red. It just has the changed domain and range. So for example, let me draw this for you. My x values are between -1/3 and 1/3. So I can choose my own scale here. I'm going to make that -1/3. That's +1/3. And my range is between -pi and pi. So y-axis for range, +pi I'm going to put up here, and -pi I'm going to put down here. Now knowing that it has to keep, I'll shrink this down so we can see my red graph as well, knowing that it has to keep that same shape, that -1 minus pi on 2, Mine's now going to be minus a third minus pi. It's going to be down here. Then it's going to go through the origin, and then it's going to be a third and pi like that. And it keeps the same shape, and that is it. So I've drawn my graph, my inverse graph. Let's try it again. Question 2. Now we want to sketch an inverse cos graph. So just for a little reminder, I have drawn the basic inverse cos graph up there in the corner, and I've written the domain and range of it down here. So it says, it doesn't say to draw it straight away. The first thing it says to do is to find the domain and range. And I suggest you should always do that, even if it doesn't ask you to, because that's the easiest way to draw it. So the first thing is we need our trig function by itself. So this 2 is in the way. Just like last time, I need to divide that away. So that means I'm going to have y over 2 equals inverse cos of 2x plus 1. Okay, so this side's going to give me the range, and this side's going to give me the domain. Okay, so my range, I'll start with range this time since it's on the left. Range for y over 2, for this graph over here in red, the range is between 0 and pi. So that y over 2 is going to be between 0 and pi. Now I don't want y over 2, I just want y. So I times by 2. 0 times 2 is 2, and pi times 2 is 2 pi. Now let's do the domain. Now I have a 2x plus 1. The domain of that 2x plus 1 must be between, looking in the red again, minus 1 and positive 1. So I have minus 1 on this side, positive 1 on that side. Now I have 2 numbers here to move away. I've got to get rid of my 2 and my 1 here. So we start with the 1. We subtract 1 from both sides. Minus 1 minus another 1 would be minus 2. If I subtract the 1 away, that means I just have the 2x. 1 minus 1 is 0. Now I want to get rid of this 2 in front of my x by dividing by 2. So minus 2 divided by 2 is back to minus 1 again. I've divided the 2 away, and 0 divided by 2 is still 0. Okay, so I have found my new domain and range. There they are. So then in part B, it now says it wants me to sketch the graph. So use that domain and range and know that it's going to keep the same basic shape as the one that we have hopefully memorized. Okay, so here we know the cos graph sits above the x-axis there, so I'm going to keep this nice and low. So x-axis, y-axis. My domain is from minus 1 to 0. So I'm going to have minus 1. 0 is obviously the origin. I'm going to have to know where minus a half is because we need those 3 dots going across there. So I need a middle point as well. We also know that the y-axis, the range, is from 0 to 2 pi. So I'm going to go 1 pi there and 2 pi there. Again, you need to know that middle point so that you can see that curve coming around. So keeping this same shape, we know that at minus 1 we're going to be at 2 pi up here, minus a half, that will be my middle point, and that will make 0, 0, my last point there, keeping that same basic curve, and we have our graph like that. Now hopefully that seems nice and easy, that these curves always keep the same basic shape. All we need to do is work out their new domain and range. The only way to make it a little bit more complicated, which I didn't put an example in, is to put some minus signs in there. because that is actually going to reflect our graph in all sorts of different ways. So I thought I'd chuck a couple of extra questions in here in the purple just to show you what happens with a few minus signs. So starting with the y equals negative inverse cos of x. I've tried to keep it fairly simple so we don't have to do too much work here for our extra question. First of all, get rid of the minus sign. So that means minus y equals inverse cos of x. My range from here means that negative y, is going to be between 0 and pi. These are the same values as from the last question for range. If you want to look back to that diagram above, you can. If I want to get rid of that minus sign in front of the y, I want to divide by a negative sign. When you divide by a negative sign, not only is pi going to become a negative pi, it's also going to turn the signs around. Now, in effect, what that means is this pi, when it becomes negative pi, it's going to come to this side, negative pi. And 0, when I divide it by a negative number, even though it's still 0, the sign gets turned around, so it's now y is less than 0, which goes here. Pretty cool, huh? All right, now our domain comes from here, which is just the x. There's no minus signs or things to make changes there. So that is still going to be between -1 and 1. So the graph for that, to draw it nice and quickly, okay, so I've got my domain between -1 and a +1, and my range is between 0 and minus pi. So if minus pi is down here, give myself a halfway point, minus pi over 2. Now, this actually means that my my first point is actually -1 minus pi. They are my first two coordinates, -1 minus pi. It starts down here. Then it would be in the middle, and then it would be 0 with the 1, 0, 1, like that. So what that does, it's reflected my curve upside down. It's reflected it over the x-axis when I put that minus sign in front of my inverse cos. What about when you put the minus sign in the brackets, which means it's going to affect the domain? All right, so let's have a quick look at that. So there's nothing to move away for this, so we can go straight to the range for this one. There's no changes there at all. The range is going to be between 0 and pi, just like before. And the domain, though, is going to have a change. X minus x is going to be between -1 and 1, which means to divide by a negative sign, 1 divided by -1 becomes a -1 that comes to this side, and -1 divided by -1 becomes a +1, which goes to that side. So they've switched sides, but it actually kind of ended up with the same thing, which is interesting. So it kind of looks like the graph has stayed the same, but it hasn't. Because when you draw it, it actually changes the direction of which way it swivels. So we have our domain between -1 and 1. We have our range between 0 and pi. Pi on 2 would be in the middle. It means that it's actually going to start here at 0 minus 1. Oh, sorry, -1, 0. So that's the wrong way around. And then here for the center and here. So it reflects it across the y-axis like that. Okay, and you can imagine that you could actually reflect it across the x and the y-axis just to get really tricky. Okay, so you might want to play around with that. Okay, one more thing to note for this exercise. we now want to look at the graphs of sine inverse sine x, cos inverse cos x, and tan inverse tan x. Excuse me. The composite function defined by y equals sine inverse sine x has the same domain as inverse sine of x, which is x is between -1 and 1. Okay, that's the key thing here. Because it is a function, the function y equals inverse sine of x, followed by the function sine of x, the composite is therefore the identity function y is equal to x. Okay, so basically what is happening is the sine and the inverse sine, they're cancelling out in effect, and we're basically ending up with the y equals x line. We're just getting this x that is in here. Okay, so, but it does have a restricted domain. So, sine inverse sine is this first graph here. Its domain is between -1 and 1, and its range is also going to be between -1 and 1 because it is a straight line. Y equals x, the domain would be the same as the range. Same thing goes for cos inverse cos. Okay, but for tan, the tan is still approaching the y is equal to x line, but we do not have the restricted domain because remember those asymptotes that were there? We had those in the tan graph that were curving around and not actually having any endpoints there. It means that we don't have a restricted restrictions here for this one either. So, if you remember those three basic forms of those basic graphs, it helps us to draw some slightly more complicated ones. So if we want to sketch the graph of y equals cos inverse cos of 2x, we take the 2x that is in here and we put that at the center of our domain. Okay, now our domain is normally for cos and sine is between -1 and 1, which is why I highlighted that up here because we're going to be using that a lot for these types of questions. So the 2x must be between -1 and 1. Now I want to get rid of the 2 just so x is by itself. So I divide everything through by 2, which means between -1/2 and 1/2. Okay, so there wasn't any changes over here for my range. That's not going to change. What has changed is my domain. So to draw the graph, my range is staying between -1. Oh, that's very messy. Let me start that again. A bit tidier, hopefully. Not much tidier, but anyway. So -1 and 1, my range hasn't changed. My domain has. So it is now going between -1/2 and +1/2, but it is going to look like this cos graph here. Okay, so I'm going to have -1/2 will be at -1. It'll go through 0, 0, and 1/2 there. And that will be my graph. Don't put arrows on the ends. Those are endpoints because we have a restricted domain. That's it. That's my graph of cos inverse cos of 2x. Okay, it's basically the graph of 2x, isn't it? Just between the restricted domain. Okay, B. We now want to draw tan inverse tan of x plus 1. Now, just like in this last graph, this was basically the graph of y equals 2x, but we had to restrict the domain because of the restricted domains up here. tan does not have a restricted domain and range. So if I want to draw tan inverse tan, the tans disappear, and I'm really just drawing the graph of x plus 1. And that's all I do. I draw the graph of y equals x plus 1. No restricted domains or range. So x plus 1 means I have a y-intercept at 1 and a gradient of 1, which means my x-intercept would be at -1. And there is my line. That's it. So exercise 17C.